Hi students, I welcome to the second session of programming in C. In this session, let us discuss about the flowcharts. In the first session, we already discussed about the algorithms. So algorithm is the first step in the programming, and the second step is the preparation of the flowchart. So you can consider this one as the second step in the programming. See, actually, what is a flowchart? The pictorial representation which shows the sequence in which data are read, computations performed, decisions are made, and results are obtained. So in other words, simply we can say that the diagrammatic representation or the symbolic representation of flowchart algorithm is called as the flowchart. See, when you are going to draw the flowcharts, to draw those flowcharts you must use some basic symbols. So here in this slide just I had shown some of the basic flowchart symbols. See, the first one is the oval box, oval in shape. This is called terminator box, otherwise called start or stop box. So this terminator symbol is used to begin and end each flowchart. So when you are going to start drawing the flowcharts, you must start that flowchart with this symbol where you can put here as the start, and that flowchart must end with this symbol and where you can write the stop. So this is called as the start or stop box. The second one is parallelogram, and this is called input or output box. So its purpose is the input and output box shows interaction with an outside entity. This may represent data being input or information being displayed to an outside entity. This is also called read or write box. The next one is process box. So the purpose of this process box is to represent just a single event which requires no interaction from an outside entity. In this box you can write the equations necessary for computations. The next one is the rhombus. This is called as a decision or condition box. So decision or say diamond creates two data flows from one. A decision box always has true or false or say yes or no written on the left and right sides. So here we can write the conditions. When that condition was evaluated, the answer of that condition may be either true or false or say yes or no. So for that purpose, for this decision box you can show two branches. One is true branch, another one is false branch, otherwise S branch or say the no branch. And the next one is the arrow. This is called flow line or data flow. So data flow connect the different symbols showing the order that is followed in the algorithm. This is the most important. Even though you have drawn all the symbols in the flowcharts, if you are not linked with one another, it is only incomplete flowchart. So you must include this flow line, otherwise you must show the data flow in a flowchart. And the next symbol is the loop or iterative box. So it is used when a problem has repetitive steps. That is, a problem has a solution with the steps repeating again and again till a condition or definite number of times. And the next one is the connector or flow linker. So this links the flowchart mostly on the same page. Connectors can also be numbered in order to allow movement from one page to another. And the last box, it is called function or procedure or say subprogram box. This can be labeled with the function or procedure name or say subprogram name. Every subprogram has end with a terminator box. So like this, we can use these basic flowchart symbols to draw the flowcharts. So, and again you must remember, while drawing the flowcharts, you must follow some rules. So here I am presenting some rules for the flowcharts. Say, every flowchart has a start symbol and a start symbol. Okay, you must start with this start symbol and you must end that flowchart with this stop symbol. And the flow of sequence is generally from top of the page to the bottom of the page. This can vary with loops when needed to flow back to entry point. And next one is use arrowheads on connectors where flow direction may not be obvious. And another rule is there is only one flowchart per page. And next one is a page should have a page number and a title. A flowchart on one page should not back and jump to another page. And flowchart should be simple and concise. Flowchart should be neat and clean. Its draw procedure should be in a sequence. It should be according to the flow of the problem. It should be properly linked with arrows. It may have numbering if needed according to the situation. So these are the simple rules you must remember while drawing the flowcharts. Okay, now let us take one simple example. Already we had written the algorithm, and for that algorithm today just I am going to show the flowchart. So here it is. This is the flowchart to add any two numbers. So I had started this flowchart with the start box. Here I had labeled as the start, and the next two I had collect two numbers from outside. That's why I had included one input box here, and this box was labeled as the read n1 comma n2. We are going to collect the first number into the n1 and second number into the n2. And next to here we had used one processing box. Here I had shown one computation as sum equal to n1 plus m2. So the calculation is over. Now we have to print the obtained result. Then for the purpose we had used another box. This is called output box, and this box was labeled as the print. So print sum. Here we had printed the evaluated value. And the last one is the stop box here to end this flowchart. So when you are going to draw the flowchart, you must start that flowchart with the start box and you must end with this stop box. In between the start and stop, we can use the required result in the required order. And remember, you must link all these symbols with these arrows. Then only it will become the complete flowchart. So just for your idea, already we had prepared the algorithm to add any two numbers, and here it is the algorithm and here it is the flowchart. See the algorithm, the first step is the start. In the flowchart also the first symbol is the start, And the second step is read two numbers into N1 and N2, and that was represented here with this input box, and here we had written as read N1 and N2. And step 3, here we had performed the calculation. So that is sum is equal to N1 plus N2. In the flow chart, this can be represented using this processing box, and that is like this, sum equal to N1 plus N2. And the next step, fourth step, print sum. Here we had printed the evaluated value, and that can be represented in the flowchart using this output box, that is like this, and print sum. And last step is the stop, and here that was drawn as using the stop box. So like this we can prepare the algorithms, and for that algorithm we can draw the flowchart. So this is the simple algorithm and flowchart, and to add any two numbers. And here I am going to show another example, and this is to add and multiply any two numbers. Just follow the previous procedure. So here it is the start, and here we are collecting those two numbers, and here we are adding those two numbers, and for that purpose we have written the expression as sum equal to N1 plus N2. And here one more calculation is there, that's why I had used another processing box, and here we had written as PRO, that is, this is to store the product, is equal to N1 and N2. And here using this output box we have printed those two evaluated results as print sum comma product. And stop, this is to end this flowchart. So this is the flowchart to add and multiply any two numbers. And similarly, let us take one more example. This is the example to find largest of any two numbers. Sometimes we want to compare one value with another value. Based on that, I am going to show this example. So this is the example to find the largest of any two numbers. So the flowchart is like this. The first one is the start, and next you can take, you can collect two values from outside. So that's why we had used the input box here, and we had written here as read A comma B. And now we have to compare those two values, and for the purpose we have used this rhombus, otherwise called decision box. And here we have written the expression as is A greater than B. It may be either yes or no, or it may be either true or false. If it is yes, we are going to collect A value into the big. If it is no, we are collecting B value into the big. And after that we are coming to this step, and here we are printing the big value. It may be either A or B. And here in this B, either A or B will be stored, that is depending on this condition. And finally we are ending this flowchart by including this stop box. So like this we can prepare the algorithms, and for those algorithms we can draw the flowcharts. Okay, like this we can write any number of examples, and in the coming sessions we can go for other examples. Okay, I hope you understood this topic. Thank you. Again we will we'll meet in the next session.